This is the second part of the notes video from Tuesday, January 26th. We are still going over these problems, and it is number 2 and number 3. So you should have those like written down or have a picture so you know what we're talking about. Okay, so number 2, barium nitrate and potassium carbonate undergo a double replacement reaction. So the first thing we have to do is write our balanced equation. So these are my reactants. Barium is Ba positive 2, nitrate is NO3 negative 1. So that formula is Ba, and we have to put nitrate in parentheses because it's a polyatomic ion, and we need 2 of them because barium's a 2. Plus potassium carbonate. Potassium is K1 plus, carbonate is a polyatomic CO3 negative 2. And so we'll need 2 potassiums because carbonate's a 2, potassium's a 1. So K2CO3 arrow. Now for your products in a double replacement reaction, an easy way to remember it is the outsides go together. Barium, or the metal here, goes with the non-metal, which is the outside over here. So the barium and the carbonate go together for my first product. Now barium's a 2, carbonate's a 2, so that is BaCO3 plus, and then the insides go together. NO3 goes with the K of this. Now, you, I hope, know you're not going to write NO3K. You always write the positive or the metal first, so that's going to be KNO3. And they're both 1s, so neither one of them needs a subscript. Now this equation is not balanced. There's 2 nitrates on the left and 2 potassiums on the left. So in front of this, I'm going to write a 2. And then this equation is balanced. So that is part 1. Okay. So problem A says how many moles of barium nitrate are needed to produce with 1.248 moles of barium carbonate. So we always start with what we're given. 1.248 moles, and barium carbonate is that. Okay, times. Now I want to solve for moles of barium nitrate. I have moles of barium carbonate. When you look at your list, I can go from moles of barium carbonate to moles of barium nitrate using this conversion. This is the only conversion that lets you go from one thing, from A to B. So from one substance to something else, and we use our coefficients. So the coefficient for barium carbonate is a 1, and I'm going to put that at the bottom. That way it cancels out that unit. So 1 mole BaCO3, and I'm trying to solve for barium nitrate, which is this, and the coefficient in front of that is a 1. And so that goes up top. Now, my moles of BaCO3 cancel out, and you're left with the unit moles BaNO3, which is what I wanted to solve for. And then you actually don't need to type this into the calculator looking at it, because it would be 1.248 times 1 divided by 1. So the answer is 1.248 moles of barium nitrate. Now for part B, I want you to change the problem. The problem says how many moles of potassium nitrate will be produced. I want us to actually solve for grams of potassium nitrate. So B, where it says how many moles, let's change that to be how many grams of potassium nitrate. Okay, but the rest will still be the same. So how many grams of potassium nitrate will be produced if we start with 0.45 moles of barium nitrate? Start with what you're given, 0.45 moles of this. So 0.45 moles barium, I don't know why I wrote parentheses there, barium nitrate times. Now I want to solve for grams of this. A lot of people will mess this up, and please don't write my next step because I'm going to have to rewrite it. and they say, okay, I have moles. I can go from mole to gram. And so they'll write 1 mole BaNO3, 2 is grams BaNO3, 2. But that's not what the question asked. The question wanted grams of KNO3. Now you can't just erase this and make that grams of KNO3, because 1 mole of barium nitrate will never equal anything about potassium nitrate. Those are two different substances. And so we actually are not using this step first. We're going to use this step second. And so, let me flip. I'm going to rewrite that. We've got 0.45 moles of barium nitrate. And instead, we can't jump into the moles to grams unit because we need to go from barium nitrate to potassium nitrate. And the only way we can go from one substance to something else is using our new conversion. So you have to do this first. So the coefficient in front of barium nitrate is a 1. 1 mole BaNO3, 2 to 2 moles KNO3. Now I've canceled out the barium nitrate unit. I have moles of KNO3. I want it to be in grams of KNO3. So now I can use this conversion where 1 mole equals the atomic mass in grams. And so because this is moles of KNO3 up top, I'm going to write 1 mole KNO3 at the bottom. And 1 mole of that equals the atomic mass of it in grams. Now, remember, this conversion is always 1 mole. So it doesn't matter that it's a 2 mole right here. This conversion is always 1 mole. So right there, you should always write 1 mole. The coefficients don't, the only time the coefficients matter is this step. Every other step, they don't matter. So we need to go find the molar mass of KNO3 to plug in up here. And so off to the side, just write it out. Okay, so potassium, you go to the periodic table, potassium is 39.098. Nitrogen is 14.007. Oxygen is 15.999, and then because there's a 3, you have to multiply it by 3. And then you add all those numbers up, and that is 101.102. And so that's my atomic mass of potassium nitrate, which comes up here. Now, let's check, did all of my units cancel? Moles of barium nitrate and moles of barium nitrate canceled. Moles of KNO3 cancel out. And I'm left with grams of KNO3, which is what I wanted. And so now I just need to plug this into the calculator. And to plug this in, 0.45 times 2 times 101.102, and then divided by, it's 1 at the bottom, so divided by 1. And that should give you, it's like 90.9 grams of KNO3. And that's how we would solve 2B that was edited. We're going to go ahead and do number 3 really fast, and then that's going to be the last example I'm going to do. So number 3 has the equation written, but it's not balanced. C12H22O11, which is known as sucrose, that's sugar, decomposes into carbon and water. So first thing, you have to balance your equation first. 12 carbons on the left, so in front of this I write a 12. And then there's 22 hydrogens and 11 oxygens, so in front of this I'm going to write a 11. And then the equation is balanced. Okay, so 3A. If you have 10.4 grams of sucrose, which is this, how many grams of carbon will be produced? Start with the number given, 10.4 grams, and you can write sucrose or you can write that. I'm going to write sucrose because I think it's easier to write. And I want to solve for grams of carbon. Now I have grams of sucrose. I need to get rid of that unit first. So to get rid of grams, we use this conversion. 1 mole is the atomic mass in grams. Now this is grams, the bottom has to be grams. So grams of sucrose and 1 mole of sucrose. Now, I'm not going to spend all this time solving the molar mass of sucrose. I actually am going to have you pause the video and you go fill that out. You go calculate that and see if you get it right. So you'll need to do that yourself. See if you can add up this molar mass correct. Now that got rid of my grams of sucrose. Now I have 1 mole sucrose. I'm trying to go to carbon. Once you get your unit in moles, you can use the new conversion, and we're going to go from moles of sucrose to moles of carbon using our coefficients. The coefficient for sucrose is 1, and I'm going to put that at the bottom so that moles of sucrose, that unit, cancels out, and that equals 12 moles carbon. Mole sucrose cancels. Now I have mole carbon. But that's not what the question asked for. It asked for grams. And so we'll use this conversion again. 1 mole is the atomic mass in grams. Now this is moles of carbon. So the bottom will be 1 mole of carbon to cancel that unit. And if you look at the periodic table, carbon has a molar mass of 12.011 grams. And then these units cancel. And you're left with the unit that you want. Now I want you to pause the video and go find the molar mass of sucrose and type all this in and see if you get the correct answer. But pause it, try it by yourself. And you better have paused the video and tried it, and you should have gotten 4.38 grams as your answer. Okay, now I'm going to help you set up B, and then you're caught up with what we did in class today. B. If 4 moles of sucrose decomposes, how many grams of water vapor are produced? So this time we're starting off with 4 moles sucrose. And again, you can write sucrose or you can write out that whole thing. And we want to change it to grams of water. Well, once you have your unit in moles, which is actually what we start with, we can use our new conversion, and we'll go from moles of sucrose to moles of water. We can't jump and use this conversion right now because I don't want to find grams of sucrose. I want grams of water. And so I can't put 1 mole sucrose and grams of water up here. Those don't equal each other. You have to use this conversion every single time. Just telling you, you'll always use this. Always. And so the coefficient for sucrose is a 1. So 1 mole sucrose. And again, I write it at the bottom so that unit cancels. And 1 mole of sucrose is 11 moles of water. Now the moles of sucrose unit canceled. And I have moles of water. Now I can go from moles to grams using this conversion. 1 mole of water is whatever the grams of water are. And again, you get this number by going to the periodic table. You add up 2 hydrogens and 1 oxygen. So off to the side, H2O. Hydrogen is 1.008, and there are 2 of them, plus 15.999. And that is 18.015, I believe. And so that will come up here. And then to type this in the calculator, 4 times 11 times 18.015. And it's going to be, there's only 1s at the bottom, so divided by 1 should be 792 grams of H2O. Now you should stop and do a common sense check. 4 times 11 times 18. Should that be a big number like this? Yes, it should, and it is. If you were doing like 0.4 times 1 divided by 2, that should be a small number. So always check your setup and make sure your math answer makes sense with the work that you've written. And that's what we did in class today.